Welcome to Hello Sift Part 2. In this second part of the tutorial, we're going to be working on the presentation layer of Sift. Sift is a full-stack environment and defines and runs code both on server-side, which we saw in Part 1, and browser-side, which implements the presentation layer. So from now on, the console log on the terminal will no longer be of so much help to you, as the code we're working on will actually be working inside the browser, and we're going to be using Chrome developer tools to debug and watch what's going on. The Sift presentation layer uses a model view controller architecture, which is common in one form or another to many front-end frameworks. In the case of Sift, the model is formed from the exports that we defined in the sift.json file earlier, and there's no further work to be done on that. We also have boilerplate code already prepared for the controller and view. Open the front-end folder of the project and then the source subfolder. The controller code is in the controller.js and the view code is in view.js. Yeah, just saying in case you haven't had your coffee yet. Let's examine the controller first. First, you'll see that the controller is implemented as an EX6 class. You can also see several pieces of code commented out, which we'll uncomment and customize to our needs. The load view method is called when a user switches to a given view in the UI. It specifies the HTML template and initial data for that view. In this case, we'll only be rendering to the summary view, so we can ignore the other cases in this switch. When export data on the server end changes, it is synced to the browser storage and triggers a call of whatever method has been bound as the storage update method in line 10. The storage update callback will request some data from storage, possibly transform it in some way, and publish it back out for the view to render. Before we go on to actually implementing the code, we're going to go back to the SDK and see the export process in action. If you remember from Part 1, we sent a curl command into the Sift with the key of my name and the value of Mike, and that printed out on the console, decorated by two pieces of text added by the JavaScript and Python nodes respectively. And remember that the bucket name was who that came out as the export. Now we'll see how that got reflected up into the presentation layer. We'll go back to the summary view, and we're going to press the delete databases button. This only deletes front-end data, and it's only temporary, so you can do that as much as you like. This will flush out any schemas that already exist. Every time you're going to change a schema, you'll be pressing the delete button to make sure that the front end gets refreshed in terms of the data schema it contains. I'll then bring back my command line and send in my curl command again, and just refresh the page so it actually loads up. Open up Developer Tools and navigate to Application, IndexedDB, and Hello SDK, which is what I've called my Sift. Here's the who bucket, which contains a key called name, and the object it contains is the last message that came up, which is Mike from JavaScript from Python. Moving back to the code, we'll start by uncommenting line 10 and binding our storage update handler, and of course uncommenting the storage update handler itself, so that we now are going to handle storage update events. The getX method called here, which actually retrieves the data for us, will change to getWho, which is the name of the bucket, and we'll uncomment the getX method, change it to getWho, set the bucket to who, and make a console log when that comes back. The other things we'll do are uncomment the storage subscription line in line 17 and change its subscription to the who bucket. That actually generates the events to the storage update handler, and we'll change the default data for the summary view to no 1. because nobody's said hello yet. Moving back to the SDK, we can see that the console log has already told us that we've hit the present view and load view methods. So we can now run our curl command again, and you'll see that the storage update method has been triggered, and it's received an object with a key of name and a value of Mike from JavaScript from Python. So we successfully run through the Sift, mirrored the data into the browser, and now had it trigger the controller code to manipulate that data. Next thing we'll do is republish that with maybe a little bit more decoration on it, just to prove that we were there, so the view can now handle it. So far our code gets triggered by the storage update event, retrieves the value that's been put into IndexedDB, but it doesn't actually do anything useful in terms of returning it. So we'll just add that into our return statement out of the getWho method, and we'll also change where it's being published to, from the default value of counts to name, because that's what we're actually sending. We'll move on now to the HTML template that's going to receive the data in its rendered state. You'll find that under the public folder in the front end directory, and the one that we were passing in for the summary view is called summary.html. As you'll see, the only content it's got in at the moment is that default I'm a Sift that we saw back on the SDK. So in order that the viewer's got some ability to know where to put things, we're going to put in a different piece of code with an ID that tells us where we can substitute in our actual value as brought up from storage. We'll now move on to the view code. The first thing we're going to do is set up a subscription to events out of the controller in a manner analogous to how the controller is subscribing to events from storage. And that's done by this line here. And we're going to use an onHello, it could be anything, but an onHello method, which is the callback that's going to get called. And it will look something like this. So our onHello callback will just do a console log to show us the data that it's received, and then it will iterate through the potential list of data items that it's received from the controller. In actual fact, there'll only be one, which we know that, but it could be many. And in this case, what we're going to do is assume that the key of each item is equivalent or matches an element ID in the DOM. And we're going to set the text content of that element to the data associated with that key. So that manages changes in data coming from the controller, but it doesn't manage the initialization data that comes from the controller as part of the load view process, and that triggers present view on the view. So we'll now put in a bit of initialization code, and that selects a document DOM element, which is of course called name, which is our span, which is going to contain the name, and we're going to set the text content to the value passed in by the initialization code from the controller. So let's try out the entire chain, and we'll see that the Sift is now displaying hello no one, hello coming from the template, no one coming from the controller initialization code. We're going to bring in our dear old curl command again and send that in, and lo and behold, that is now rendering the message generated through the Sift chain and up into the controller, into the presentation layer. That completes the basic functionality of our Hello World Sift. However, there are a couple of points that we have to cover before we can put our Sift into the production environment. These mainly revolve around the nature of the webhook. If you remember, we obtained the webhook URI by copying it from the workbench and then pasting it into a terminal window. However, the webhook signature changes with every instance of the Sift that is installed, so it will be different in the production environment, and the end user will have no means in the dashboard to copy that hook URI. So we're going to have to provide a bit of UI functionality so that when we install the Sift into the production environment, she can use the webhook to generate the curl command as we have done during development. This is obviously a very artificial situation, but it will show us how to retrieve the webhook signature in the presentation layer, and that will be needed when we present the user with forms or buttons or some other kind of UI component which will send back data into the Sift. So there is very much a real-world application for this. We'll start by modifying the controller code to return a slightly different set of data. Up till now it's been just telling us that the name was no one. Now we're going to have a webhook retrieval method, which is a promise, and when that promise completes, we're going to be returning an object with our name of no one and the hook URI. So now we're going to write our getWebhook function, which is almost identical to the getWho function, which is retrieving values from the export. In this case, this is retrieving it from a bucket which is the underbar Redshift bucket, which is used to get system information back. And the key we're going to look for is webhooks curl input, where curl input was the name of our webhook. And we need to get rid of that extra. Now we're going to change our summary template to put a placeholder in for the insertion of the webhook URI, which is here, the ID hook URI, and we'll also just put in a bit of explanatory text. Moving back to the browser, we can see that we've now got our explanatory text, and we printed out the webhook URI, which is nice, but it's a bit on the big side, so a touch of styling would help. Like that, and we'll let that build. So we'll look once more to the browser, and we can see that we now have our curl command printed out nicely on the web browser. Bring back our terminal, substitute in name and mic, and the functionality is still there. So now we've completed our development of our Hello World Sift. We're going to move it into the production environment. And this is a very simple process. It really just consists of making a GitHub repository which has got our code in it, and any GitHub repository that has got a sift.json file that can be found by Redshift will be listed on your workbench in your dashboard. By going to the Redshift dashboard, and go to the workbench and connect to GitHub. I've already made a couple of Sifts, as you can see, but your workshop will be empty when you start. So we'll go to GitHub, and create a new repository, which we're going to call My Hello. So moving back to our project directory, we'll start by initializing the Git repository and create a git ignore to get rid of node modules and such like that. Now we'll add our source files and commit them And finally, set a new remote as per GitHub's instructions. Check it. Looks good. And push the changes to GitHub. Moving back to the dashboard, we can see in the workshop that we have indeed published our Sift, which we can now set to run. Go to the dashboard where we will find it. We can now test out the cloud webhook signature, that is. And we'll see that this functionality is the same as it was in the SDK. That concludes the Hello Sift tutorial. Let's just review what we have achieved. We've created a stream processing pipeline implemented in 2 completely different languages that communicate seamlessly. We've integrated the output of that pipeline into a progressive web application with efficient real-time presentation. And finally, we have deployed into a zero-maintenance, serverless production environment with massive scaling abilities. Thanks for watching.